In this lecture, we will discuss simplification of grammar, in which we will discuss removal of useless symbol. Now, when we construct a compiler for any programming language, then we need to write a grammar. When we write a grammar, then we need to write hundreds of rules. Then there may be the cases that some useless symbols may occur. So, we need to remove those useless symbols. Now, first of all, we should know what is a useless symbol. Suppose we have a grammar G is equal to NTPS, which is a context-free grammar. A symbol X is useful if there is a derivation S drives alpha x beta, which further drives W. Here alpha x beta is a sentential form, means after applying some steps or after applying some rules, we get this sentential form. This asterisk symbol represents that we get this derivation after the application of some rules. Fine. So, here alpha and beta may be terminals or non-terminals, but W is the terminal string. If this condition satisfy, then X is a useful symbol, otherwise X is a useless symbol. Now here, we are having two conditions. First condition is that there should be a terminal string derivable from X, means this condition must satisfy. X is useful if we are able to derive a terminal string. Okay. Second condition is that X should be derivable from S. Both these conditions should be satisfied. First is that their terminal strings should be derivable from X. Second condition is X should be derivable from S. Now, these two conditions are necessary conditions but not sufficient conditions. Now, let's see why. Consider this example. S tends to S drives alpha A B beta. Next rule is A drives X. Now, look at this symbol A. Symbol A is satisfying both the conditions. From A, we are able to derive this terminal string. Here, S, A and B are non-terminals and alpha, beta and X are terminals, right? So, this symbol A is satisfying both the conditions that we are able to derive a terminal string from A, and A is derivable from S. But in this grammar, if we don't have any rule from which we can derive a terminal string from B. Look at this. In this rule, we are having A, B. Both the symbols are there. But if we do not have any rule from which we can derive a terminal string from B, then in this case, this rule will be useless. If this will be useless, that means A will also be useless. So that's why we say that these two conditions are necessary conditions but not the sufficient conditions. Right? Now let's take an example. Let's consider this example. S tends to AB, S tends to AC, B tends to B, S tends to BC, and so on. These are the rules. And we need to find out the useless symbols to remove those useless symbols. Here, A, B, C, E belong to non-terminals, and A, B, small letters of A, B, C, D belongs to terminal symbols. Right? Now, first of all, look at the rules where at the right hand side we have terminal strings. So, in these rules, we are having two rules where we are getting the terminal symbols. B tends to B, it is producing this terminal symbol, and this is a terminal string. Means for finding useless symbols, these new grammar will be generated, and in this new grammar the non-terminals will be, suppose the non-terminal is and dash, then this B and E should be included in the new grammar, right? Now we include B and E in the new set and dash. Now find out the rules where B and E are occurring at the right hand side of the rules. Here suppose we take E. Here E is occurring, here we are having two rules where E is occurring at the right hand side of the rules. Then look at the left hand side, E is already there in the and dash. Here we are having C. C is there at the left hand side. Then include C also in and dash set in the new grammar, right? So now we are having and dash is equal to B, E and C. Now again look at the symbols, look at the rules where these symbols are occurring at the right hand side of the production rules. Now again check. Here we are having B, this is A and C, which is already there in and dash. So S is also there. We can add S also in and dash set. Fine. So finally we have and dash is equal to SBEC. Now keep on repeating this procedure and try to find out all the non-terminals. Now we see that we are not able to find new useless symbols here, or we are not able to find out new symbols which can be added to and dash. Now check here, we have used this rule, right? But we have not used this rule. Here look at these rules. Here A is not producing any terminal string. Means A is a useless symbol. If A is a useless symbol, means that all the rules which are including A will become useless, right? So in this case we have S tends to A, B. So this rule will become useless cause A is a useless symbol, cause it is not generating any terminal string. Similarly, S tends to AC will also become a useless rule. So we are having these three rules useless rules, right? So because A is useless, so all the rules involving A will be useless. Now consider next example. Here S tends to AB, S tends to A and A tends to A. Remove useless symbol. In this grammar we want to remove useless symbols. Now here A is a terminal symbol, right? So apply first condition here. When we apply first condition, then what happens? That add all the non-terminals which are producing a terminal symbols or terminal string. Here we are having two rules which are producing terminal symbols. So add S and A to the new grammar, to the new set and dash, right? Next, here B does not produce any terminal symbol. That means B is a useless symbol. If B is a useless symbol, that means this S tends to AB will be removed, right? So after applying first condition that every non-terminal should generate some terminal string, then we can have S tends to A and A tends to A. But cause B does not derives any terminal symbol, that means B is a useless symbol, and hence this rule becomes useless. Right? Now, consider second condition. Now, we have applied first condition, then we get these two rules. Now, apply second condition. Second condition says that any non-terminal symbol should be derivable from S. Here we have only these two rules. S is the starting symbol. This is the valid rule. Now take this one. This is S tends to A. Now here A is not derivable from S. So now A becomes useless symbol. Fine. So only S tends to A is the valid rule in the grammar, and A tends to A will become useless. Fine. Now, for removing useless symbols, we should apply both the conditions in the particular order. Means we should apply condition first and then we should apply condition second. Now, let's see what happens if we apply the conditions in different order. Means we apply the condition second first and then we apply the condition first. Take the same example. Now if we apply condition second according to this, that every non-terminal symbol should be derivable from S. This is the second condition, right? So if we consider this grammar, here every rule, see this S is the starting symbol, then no doubt it will be included, right? And here A tends to A and A is derivable from S. So in this case, if we apply second condition, then in this case no rule will be eliminated, right? Because all these rules are satisfying the second condition, that all the non-terminals should be derivable from S. Now, apply the first condition. First condition says that every non-terminal should derive terminal string. Then in this case, we have S tends to A and A tends to A. But B does not derive any terminal string, so this will become useless and we will remove this rule. But look at these rules. Are these valid rules? No, these are not valid rules. Here A tends to A. Now these two rules does not satisfy both the conditions, where the first condition says that each non-terminal should derive a terminal string, and the second condition is that non-terminal should be derivable from S. Non-terminal or the sentential form should be derivable from S. So here A is not derivable from S. So if we change the order of the conditions applied, then it is possible that we are not able to remove all the useless symbol. So it is necessary to apply the conditions in particular order. First apply condition 1 and after that apply condition 2 to remove all the useless symbols, right? Now if we have a grammar which is having all these things, like we have a grammar which is having epsilon productions, unit productions and useless symbols. If all things are there, then first of all we need to remove epsilon productions from the grammar, because when we remove epsilon productions, then we may have unit productions. We may produce some unit productions. Okay. Second, we should remove unit productions, cause when we remove unit productions, then we may produce some useless symbols. Okay, and finally we should remove useless symbols. See, if we will change the order of this sequence, then also we will not be able to simplify the grammar. Okay, thank you.